think we'll go ahead and get started. Hello, I'm Cheryl Rasmussen, and welcome to our live community event, the topic of Global Protect, secure and seamless remote or workforce deployment. So thank you for joining. We wanted to let you know that the Q&A is enabled, so if you have any questions, please enter them in there for our experts to answer. We'll allow some time after the presentation to address any questions that do come in. And please remember to also go to the event page on Live Community, where you can comment and keep the conversation going after the event concludes. And this is also where you can go to see a recap of all the questions and answers from today's presentation, and also view the recording. So I wanted to now introduce you to our speakers. We have Nahal and Varun, both coming to you with many years of experience with Global Protect. And with that, let's go ahead and hand it over to Nahal.
Thank you, Chair. Good morning, everyone. Thanks for joining us for this live event today. So as we know, security of the remote workforce is a critical need for any enterprise today. So that's what I'll be covering as a part of my presentation, securing Global Protect deployment. So following will be agenda of my presentation. I'll start with some of the problem and challenges with current IP-based blocking. Then I'll go over reliable way to identify and quarantine of the compromised device. I'll go over methodologies for doing so, such as manual quarantine, auto quarantine, XML API-based quarantine. Followed by that, I'll cover some of the actions we can take on the quarantine devices. Then I'll go over how can we notify the Global Protect endpoint about this quarantine activity. And then I'll follow it with how can you redistribute this quarantine list in the Prisma Access infrastructure and gateways. And then I'll conclude my part of the presentation with some troubleshooting methodology and deployment strategy. So let's get started. Next slide, please, Varun. So as we know, customer realizes that the current security solutions, which rely heavily on the IP address-based blocking, they are not adequate for the modern advanced threats we see in the network today. So take an example, malicious activity can be seen from the endpoint. Then Prisma Access will automatically restrict the network activity from that endpoint using the IP address. But the reality is that the IP address of that endpoint can change, and the endpoint can reconnect to the Prisma Access infrastructure. Endpoint can access the application and data as long as it does not trigger the traffic that appears malicious to the Prisma Access again. So as we can see here, the endpoint connects with the IP address of 10.1.1.50, which is a compromised endpoint. And then Prisma Access will block that endpoint. But if the IP address of the endpoint changes, then that endpoint will not be blocked and it will be allowed access to the application and data as long as it does not trigger the traffic that appears the malicious signature to the Prisma Access infrastructure. Next slide, please. One more time, please. Thank you. Yeah. So as we can see here, originally the device connected with IP address 10.1.1.50, then the IP address got changed. So even though the original IP address was blocked on the Prisma Access infrastructure, the device can reconnect to the Prisma Access with a different IP address. Next slide, please. Thus, as we have seen, there are some challenges with this current IP-based blocking. One is identification and quarantine of the compromised devices. There are no reliable way to do so. And the second, once the compromised devices are blocked using the IP address, then those devices can connect back to the infrastructure using a different IP address. Next slide, please. That's where Palo Alto now introduced reliable way to identify and quarantine the compromised devices with this new capability. With this feature, Global Protect reports the endpoint hardware serial number and host ID to the Prisma Access at a connection time. Prisma Access can automatically restrict the network activity from this malicious endpoint using endpoint serial number and unique host ID. Hence, even though the IP address of the endpoint changes, then endpoint can still remain quarantined and Prisma Access can track this compromised device. So as we can see here, even though the IP address of the device changes, still Prisma Access will be either able to block or restrict the access from this compromised device, as we are tracking this compromised device using the unique host ID and hardware serial number. Next slide, please. So now let's go into a little more technical details of this functionality. So there are three primary ways to identify and quarantine these compromised devices. One is a manual quarantine. So manual quarantine can be done by network admin or SOC, either by adding the device host ID and serial number into the quarantine list manually, or adding the device host ID from either traffic, threat, global protect, heap match, unified, or correlation logs to the quarantine list. The second method is auto quarantine. Auto quarantine can be implemented using log forwarding rules. Again, here we can utilize traffic, threat, global protect, unified, and correlation events. And in the log forwarding profile, we can configure the filter specific to different events to automatically add the device to the quarantine list. And the last method is the API quarantine. Here we can utilize the API commands available for this feature. Then these commands can be either utilized by third-party security solutions to add or delete the device from quarantine list, as well as to view the quarantine list available. Next slide, please. So now let's go ahead and go into a little more technical details of each of these methods of the device quarantine. So first is a manual quarantine. So manual quarantine, as I mentioned earlier, can be done by admin or a SOC admin by adding a host ID or the serial number of this device manually to the quarantine list. The device quarantine option, which is newly introduced, is available on the panorama under device quarantine option. Admin can add a host ID or the serial number manually to this quarantine list and quarantine the endpoint. Host ID is mandatory to add a device to the quarantine list, but serial number is optional. Next slide, please. Again, the second method to do a manual quarantine, as I mentioned, is via logs. So admin can manually add a device to the quarantine list from either of these logs. Global Protect log, where host ID is populated by default, traffic log, threat log, heap log, unified, and correlation logs. So as we can see, we have a newly introduced host ID column, and admin can click on a specific host ID. Here, as we can see, admin want to block a device which is exhibiting a critical threat. Then he can click on the host ID of that endpoint, which is exhibiting the critical threat, and add the device to the quarantine list by doing a block device. Next slide, please. Yeah. So second method is auto quarantine. So for auto quarantine, we can utilize a log forwarding profile. And within the log forwarding profile, we can define a filter condition and also define a built-in action as a quarantine to automatically add the device to the quarantine list. So as we can see here, here we have configured a log forwarding profile for advanced persistent threat called muddy water. And as a part of this log forwarding profile filter, we are looking for specific URL related to this muddy water APT. Right? So as soon as the device observes this URL within the threat log, then as long as we have specified the built-in action as quarantine, the device will be added to the quarantine list automatically. Now, just configuring the log forwarding profile itself is not sufficient. Hence, you have to also apply this log forwarding profile to the security policy. So as we can see here, once configured log forwarding profile, we have applied this log forwarding profile to the security policy for the auto quarantine. Next slide, please. The last method for quarantine is, as I mentioned, is an API quarantine. So again, same thing, device can be added to the quarantine list, deleted from the quarantine list, or we can also view the existing quarantine list using the API commands available for this functionality. So as we can see here, we have a command for adding a device host ID to the quarantine list, deleting a device from the quarantine list, either using host ID and serial number. And we can also check the list of the quarantine list. Next slide, please. Quarantine activity log. So all the activity related to the quarantine features is available under the Global Protect logs, which are available in Monitor, Logs, and Global Protect tab. Each of these logs are available for a different stage, as we can see here, login, quarantine, and so on. And within each stage, we have a different event ID, which is also listed. So as we can see here, we have a quarantine add event within the quarantine stage. We have quarantine delete event. And at the same time, we can also see what was the reasoning for device being added to the quarantine list. As we can see here, a specific host ID and endpoint was added to the quarantine list manually by admin. The next one, which was added to the quarantine list by malicious traffic. Next one is the quarantine list. So once the device is added to the quarantine list, then admin has a detailed view of that device in the quarantine list, which is available on Panorama under Device Quarantine tab. So as we can see here, as a part of this detailed list, admin can see the host ID. Admin can also see the reason why the device was added to quarantine list, whether it was manually added to quarantine list by admin or whether it was due to auto quarantine being triggered. We can also see the timestamp when the device was added to quarantine list. We can see the serial number of the endpoint. We can also see the username connected. And we can also see the source device or the app which added the device to the quarantine list. Next slide, please. So just adding the device to the quarantine list itself will not trigger any kind of quarantine actions. That's where we have few actions we can take on the device which are added to the quarantine list. So first action is block the login from the quarantine devices. For that, we have provided a block login for quarantine device option on the Global Protect gateway on the authentication tab, as we can see here. So once we enable this option, then the device which is added to the quarantine list will be automatically disconnected from the existing Global Protect VPN connection, as well as if it tries to reconnect, login from that device will be blocked as well. Again, this is a very strong quarantine enforcement and it needs to be carefully reviewed before enabling. Next slide, please. The second action for the quarantine devices is security policy enforcement. So here, the actions can be taken for the quarantine devices based on the security policy. So as a part of security policy, we have introduced the quarantine option under source and destination device, as we can see here. So based on this security policy, you can define whether you want to block the traffic originated from the quarantine device or whether you want to block the traffic destined to the quarantine device, either of those. Next slide, please. Again, as we have seen, this is the second option. So first option, what we saw was blocking the login from the quarantine device. So if you enable that option, then user will not reach this stage because the login itself from that endpoint is blocked. But if you have not enabled that option, as it's a strong enforcement, and you want to restrict the traffic from that endpoint, then you can utilize the security policy based enforcement, where you can define a policy for the quarantine device. As we can see here we've defined the quarantine policy to completely block the access from the quarantine devices to our corporate sensitive resources. You can also apply restrictive quarantine policies based on your need for your sensitive resources. Next slide, please. So how do we notify the end user about this quarantine activity? if the endpoint is compromised. So that's where the Global Protect client notification helps us. So as we can see, under network portal agent and app configuration, we have defined quarantine messages when the device is added to the quarantine list or when the device is removed from the quarantine list. So by default, there are default messages available, which will be notified to the end user when the end user endpoint is either added to the quarantine list or removed from the quarantine list. But both of these messages are customizable. So you can define your own messages which you want to notify to the endpoint and the user when the device is added to the quarantine list or if it is removed from the quarantine list. Next slide, please. Okay, so as I shown earlier, the message defined for quarantine activity on the portal under agent app configuration are notified to the endpoint via Global Protect client. So as we can see here on the first screenshot, if the user is added to the quarantine list, then he will get notification that access to the network from his device has been restricted as per the organization security policy, and the user needs to contact the IT administrator. Similar way, let's say once the IT admin fixes the problem with the endpoint and the user try to reconnect, then he will be notified that access to the network from his device has been restored as per the organization security policy. Again, both of these messages are default messages and can be customized as per the need. Next slide, please. Redistribution. So as we saw, we can add the device to quarantine list. We can also apply the action. But at the same time, consistent threat protection from these compromised devices, regardless of the gateway location they connect to, it is quite critical. That's where we can use the redistribution functionality of the quarantine list within the Prisma Access infrastructure to redistribute the quarantine list in the Prisma Access. So as we can see, the quarantine list within the Prisma Access infrastructure can be redistributed among the different mobile user location, right? So let's say originally if the device connected to mobile user location 1 and then the device got quarantined due to the malicious activity, and now if the user tries to connect to mobile user location 2, then as the quarantine list of this mobile user location 1 is redistributed among the Prisma Access mobile user location, if the user tries to connect to mobile user location 2, access for that user can be blocked or restricted as per your configuration using the quarantine feature. As we can see, we can also see the path on how the quarantine list gets redistributed from the mobile user location 1 to mobile user location 2 via Panorama and the service connection. Next slide, please. Again, redistribution of the quarantine list can be done among the Prisma Access mobile user location and your on-prem next generation firewall or gateway as well. So depending upon your configuration, redistribution can be done among the multiple mobile user location as well as your Prisma Access mobile user location and your on-prem mobile user gateway and firewall. Next slide, please. Now let's go over some of the monitoring and troubleshooting aspect and prerequisite and licensing for this feature. So as a part of prerequisite, you will need a Prisma Access 2.0 innovation plugin and Panorama 10.0 and above. If you're going to utilize this feature on your on-prem environment, then you will need a PanOS software version 10 or higher, Global Protect client version 5.1 or higher, and Global Protect has to be installed and active on the endpoint. In terms of licensing, there is no additional license required for the Prisma Access mobile user. But if you are on-prem Global Protect customers, then you will need a subscription Global Protect license for your next generation firewall for you to consume this feature. Next slide, please. Monitor and troubleshoot. So we also have introduced certain activity tabs for this functionality. So as we can see, if you want to troubleshoot this feature, then you can start with the Global Protect logs and see the quarantine activity within the Global Protect logs under Monitor Logs and Global Protect. You can also review the quarantine list within the Device Quarantine tab. At the same time, if you would like to see the graphical view of the quarantine activity, then you can go to the ACC widget where we have introduced Global Protect quarantine activity. Here you can see why the device was added to quarantine list, reasoning for that, actions taken, and the locations where the device were added to the quarantine list. Next slide, please. Last, so we will also review some deployment strategy. So if you want to utilize this feature within your network, then you should ideally begin with the manual quarantine-based monitoring. So here, as I mentioned earlier, in manual quarantine, admin, network or the SOC admin will review the traffic, threat, Global Protect, and correlation logs to see the malicious activity or abnormal activity from the endpoint. If they think the device has been compromised, then they can manually add those devices to the quarantine list, and the quarantine activity can be performed on those devices which are manually added by admin to the quarantine list. As mentioned earlier, as a part of quarantine policy enforcement, admin can either define security policy to fully block access from the quarantine devices, or admin can also have a restrictive quarantine security policy where admin can indicate that admin want to only block access to the sensitive corporate resources from the quarantine devices and allow the rest of the access. Once you have defined the security policy and you are using the manual quarantine-based enforcement and you feel comfortable enough with this feature, then you can also utilize the auto quarantine features for the critical threats based on the careful evaluation. As mentioned, with auto quarantine, once the signature or the filter defined in the log forwarding profile triggers, then the device will be automatically added to the quarantine list based on this trigger, and the quarantine policy enforcement will be applied. Hence, you want to review the step 1 and 2 carefully, and then once you feel comfortable and understand the functionality properly, then you can enable the auto quarantine in your environment. Again, only if needed and IT remediation is not dependent on the endpoint being reachable over the tunnel, then enable the block login for the quarantine devices on the Global Protect gateway. Next slide. Okay, with that, I've concluded my part of the presentation, and I'll hand over to my colleague Varun for him to go over the seamless Global Protect deployment using the authentication override cookie. Thank you.
Yeah, thanks, Nihal. Hey, everybody. This is Varun, and I'll be walking you through how to enable seamless Global Protect deployment using authentication override cookies. So this is basically the agenda for this half of the session. So basically what I want to do is I'll provide a quick overview of the authentication override cookies. Basically talk about what pain points are resolved by the authentication override cookies. Then go over some of the benefits of these auth override cookies, and also obviously, tell you how this, enhanced usability does not come at the cost of security, and, go over the security aspects of the authentication override cookie as well. So let's dive right in. The recent global pandemic has accentuated the need to provide a great digital experience for remote users. Before being given access, end users must first establish their identity. And this has called for strong authentication with a great user experience. So how are these authentication schemes selected to allow access to corporate resources? The type of authentication method and the authentication servers to use with Global Protect vary from one enterprise to another. These are largely driven by the enterprise's security and compliance requirements. Adoption and eventual rollout of security solutions such as GlobalProtect is dependent upon providing a seamless user experience along with great security. GlobalProtect supports many different authentication mechanisms, like those requiring username password or PKI client certificate-based authentication methods. With GlobalProtect, end users on Android and iOS, that is your mobile device users, could be authenticated a certain way, versus end users using desktop OS platforms like Windows and Mac OS could be authenticated a certain way, providing greater flexibility while defining auth mechanisms, and thereby providing a superior user experience. Now, let's take a look at problems that are faced by the end users while authenticating and gaining access to corporate resources. As we all know, if the user authentication is performed using LDAP, Radius, RSA, or SAML, it requires manual input. If the user signs out and signs back into the solution frequently, so would be the need to enter credentials manually. Enterprises require users to input OTP as part of their authentication scheme, which could also impact user experience. This requires manual user input since the user has to look for a device that receives the OTP code as a SMS or an app push notification. Imagine having to enter OTP for every gateway that you would select and authenticate. User credentials will have to be saved in order to provide seamless access, but this would require the password to be saved on the device. So these examples basically show that great security comes at the cost of usability, but it doesn't really have to be that way. Enter authentication override cookie. Here are the tenets of the authentication override cookie. Number one, enhanced user experience. It helps provide a seamless user experience without requiring manual intervention. It is important to note that the user has to manually authenticate the first time, and after which a cookie gets generated, and the user input will no longer be required for the duration of the cookie's validity. Number two, usability with security. This enhanced usability improvement does not come at the cost of security, which is really, really important. Cookie is encrypted by the certificate chosen by the admin while setting the cookie-based authentication. Number three, consistent user experience for on-prem and cloud identity stores. Users' credentials need not be saved on the endpoint to provide a seamless user experience. The authentication override cookie works with username password-based authentication standards like LDAP, RSA, Radius, SAML. And whether it is your on-prem or cloud identity store, the authentication override cookie can be used to provide this seamless user experience agnostic of your identity store. Now, let's take a look at how to enable the authentication override cookie on the portal. So you can navigate to the setting by going to Network, Portal, Agent, Configuration, and then Authentication, as you can see on the screenshot. On the portal, you could generate and accept the cookie for authentication override by selecting the checkboxes visible in the portal client authentication configuration. By selecting Generate Cookie for Authentication Override, this will allow the portal to generate encrypted endpoint-specific cookies. The portal sends this cookie to the endpoint after the user first authenticates with the portal. By selecting the Accept Cookie for Authentication Override, this will allow the portal to authenticate endpoints through a valid encrypted cookie. When the endpoint presents a valid cookie, the portal verifies that the cookie was encrypted by the portal, decrypts the cookie, and then authenticates the user. Setting a lifetime is super important so that you only accept the cookie for a specific time span, after which you would require the end user to authenticate. You can specify this in terms of hours, days, or weeks. And the typical lifetime is 24 hours. After the cookie expires, the user must enter the login credentials, and the portal subsequently encrypts a new cookie to send to the user endpoint. It is also important to include the certificate to encrypt and decrypt the cookie. So now let's take a look at how this can be enabled on the gateway. As you may very well know, Global Protect architecture has two different constructs. One is the portal, the other one is the gateway. We saw how we could enable the authentication override cookie on the portal. Now let's take a look at how this can be enabled on the gateway. So similarly, on the gateway, you could basically generate the cookie and accept the cookie for authentication override by selecting the checkboxes that are visible in the gateway client authentication configuration. And similar to the previous section, by selecting the generate cookie for authentication override, this will allow the gateway to generate an encrypted endpoint specific cookie. The gateway sends this cookie to the endpoint after the user first authenticates with the gateway. And by selecting the accept cookie for authentication override, this will allow the gateway to authenticate endpoints through a valid encrypted cookie. When the endpoint presents a valid cookie, the gateway verifies that the cookie was encrypted by the gateway. It decrypts the cookie and then authenticates the user. It's also important to set a lifetime so that the authentication override cookie is only valid for a specific time span, after which you would require the end user to authenticate. And after the cookie expires, the user must enter the login credentials, and gateway subsequently encrypts a new cookie to send to the user endpoint. So the advantage of doing this on the gateway side is that once these checkboxes are selected for accept or generate a cookie for auth override, this will work for all gateways, provided the user and the OS from which the user is trying to access match the gateway configuration. And generally, we've seen our customer deployments have multiple gateways, and in which case, if you were to enable the setting on the gateway configuration, as long as the gateway configuration matches the user group or the OS the user is actually accessing from, then this will apply to those sets of users. So now let's go through an example of the authentication override cookie. So in this example, let's just explore how the authentication override cookie works. So we know that Global Protect supports both the on-demand and the always-on connectivity. And for the sake of simplicity, let's assume that in this example, it's a case of on-demand connectivity, which means that the end user, being a partner or a contractor, has to initiate the Global Protect connection manually. So you can see that the authentication override cookie is generated and accepted by both portal and gateway. On-demand is the connect method, which means that the user has to initiate. And you can also see that the cookie lifetime is set to 24 hours on both the portal and the gateway. Let's assume that the same certificate is used to encrypt and decrypt the cookie. And let's assume that this applies to all the gateways. So in this case, assuming that the connect method is on demand, like I said before, the end user initiates the connection from Global Protect on a Windows 10 machine, for example, through the portal. And a sample portal name that I've taken is the alvisofincorp.gpcloudservice.com. And so the Global Protect connects with the portal, and the user authenticates using username password credentials based on the admin selected authentication mechanism. And as you know, this authentication override cookie would work with LDAP, Radius, RSA, and SAM. So step number 2 is that the cookie, if the option is selected, the cookie gets generated based on the the portal setting, and it is valid for 24 hours for portal authentication. Let's say that the timestamp of the cookie generation is 9 a.m. Pacific. So let's say that it's 10 minutes past 9 a.m. and the user manually selects a gateway, for example, US West, for which the previous cookie that was generated is used. This cookie gets accepted because the gateway only accepts a cookie with lifetime of less than 24 hours. And it has only been 10 minutes since the previous cookie was generated. If the user chooses to authenticate against any gateways within the 24-hour time period, then the user will not be required to input the credentials manually. So step number 4 is that let's assume that we're talking about the next day. So it's been past 24 hours. So at that point in time, if the user were to manually select another gateway, then in that case, the cookie is resent to the gateway, which gets rejected, and then the user has to manually enter the credentials to log into the gateway using an admin set authentication mechanism. So in this example, it's important to remember that the same certificate was used to encrypt and decrypt the cookie. If the user were to manually switch a gateway within the 24 hours interval to US East or any of the other gateways that are present in a customer deployment, then the manual user input will not be required. Even when the auth override cookie is valid, and if the user signs out of GlobalProtect, auth override cookie gets cleared, and user is expected to manually enter credentials for the authentication to go through. If the same user were to authenticate to the portal or gateway from another device, the user would have to key in credentials manually, since the same cookie cannot be used across multiple devices. The last one is the cookie validity is checked on the server side, which is the portal or the gateway. And GlobalProtect, I'd like to point out that the GlobalProtect app is not aware whether the cookie is valid or not. It is something that the firewall can actually determine. And the GlobalProtect app will always send a cookie if present. If the cookie is invalid, then the firewall will trigger a regular authentication based on the authentication profile. So, of course, when everything works well, everything's good. But then, let's say that the end user were to report an issue to the admin saying they are required to manually input these credentials. In that case, of course, what is helpful is tools for troubleshooting. So the end users might complain that they're required to enter credentials and the cookie-like experience is not working as expected. So to confirm whether or not it is expected behavior, it is incredibly helpful to view the logs corresponding to the cookie-based authentication. This visibility is paramount to troubleshooting issues. So there are 2 separate log categories that contain this information. So if you are a customer that's using PAN-OS 9.1 and above, you can see that the GlobalProtect log category is supported. This has a record of the cookie-based authentication for both successful and unsuccessful attempts. It provides reasons why the cookie wasn't accepted, helping the administrator further troubleshoot and determine the root cause as early as possible. So in this example, you can see that initially for the successful authentication, the source user 11 with the host name was able to authenticate with a public IPv4 address. And the auth method that was used was cookie. And in the unsuccessful attempt, you can also see that it is the same user trying to access the portal authentication using the same IPv4 public address, but the cookie had expired, and as a result, the user was required to manually input the credentials. So the other log category is the system log category that can be used by admins to troubleshoot cookie-based authentication issues. So the system log category, again, contains informational logs pertaining to whether or not the cookie authentication was successful. If not successful, it also contains reasons like why the cookie expired, etc. This is helpful for customers who currently use PAN-OS 9.1 and below. For 9.1 and above, the GlobalProtect logs and the system logs help provide comprehensive information helpful to quickly troubleshoot authentication-based issues. And as you can see from the screenshot for successful authentication, even in system logs, it clearly shows you that the authentication event was for the GlobalProtect authentication. The authentication had succeeded. The login is also recorded, the IP address login. And also the username and the auth type is also recorded, as you can clearly see. And for the unsuccessful attempts, it also gives you why the authentication failed. And in this case, it was a reason of the cookie being expired, where the auth type was still cookie. So we looked at enabling and improving the user experience for a single user. Now let's take a look at how this enables a more seamless Global Protect deployment itself. Number one, user experience across OS platforms. Enterprise deployments are not specific to just one platform. In our customers' deployments, we've seen Global Protect being deployed on a multitude of OS platforms. Whether it is Windows, Mac OS, Linux, Android, or iOS, the authentication override cookies are supported, thereby providing a consistent and seamless experience across the various OS platforms. User experience across the authentication mechanisms. The need to support different types of users and devices prompts enterprises to go for a combination of authentication mechanisms. Authentication override cookies are supported on username password-based authentication like SAML, LDAP, RSA, Radius, thereby providing a seamless user experience across the different authentication methods. User experience across deployments. Enterprise deployments could be pure NGFW or pure Prisma Access, or a combination of the two. Authentication override cookies are supported on both these types of deployments. Customers who are looking to migrate from NGFW, that is the on-prem firewall, to Prisma Access, no longer need to worry about providing seamless experience, since the authentication will not break during migration, and the same authentication schemes are supported on both the NGFW and Prisma Access. So all of the seamless user experience with the authentication override cookie does not come at the expense of security. Firstly, the authentication override cookie is encrypted using the certificate chosen by the administrator while enabling the authentication override cookie on the portal or gateway. And even on the device, it stays encrypted. Secondly, to configure the Global Protect portal or gateway to accept cookies only from endpoints with a specific IP address or with a specific IP address range, enable the option to restrict the authentication cookie usage for automatic restoration of VPN tunnel or auth override, as you can see in the screenshot, to one of these values, and then configure the following. So if you select the original source IP for which the authentication cookie was issued, the authentication cookie is valid only if the public source IP address of the endpoint attempting to use the cookie is the same public source IP address of the endpoint to which the cookie was originally issued. Now let's take an example of, let's say the user connects from home and the home network, and the cookie gets generated upon successful portal authentication. So this cookie can only be used as long as the user's public IP address is the one corresponding to their home network. So when this user goes to a coffee shop and accesses corporate resources via Global Protect, the same cookie cannot be used. This would require the end user to authenticate once again, after which a cookie is generated for use for the coffee shop public IP address. So the third setting is you can actually restrict the authentication cookie usage to the original source IP network range. So in this example, what will happen is that if you select the original source IP network range, the authentication cookie is valid only if the public source IP address of the endpoint attempting to use the cookie is within the designated network IP address range. You can enter a source IPv4 or IPv6 net mask to define the subnet mask of the network IP address range for which the authentication cookie is valid. Like, for example, you could enter 32 or 128 and restrict the authentication override cookie usage to a specific network range only, instead of a specific IP address like you saw in the previous slide. So now let's take a look at how authentication override cookies are commonly deployed in our customer base. How it is deployed, of course, varies greatly across the different customers. And it also varies based on the desired user experience and the authentication that is required. We've seen that from a customer deployment perspective, where they are using non-browser based authentication like LDAP, Radius, and RSA. We've seen customers use the generate cookie on both portal and gateway and accept the cookie on both. And this would be highly required for customers that want to promote a more seamless user experience. And of course, the cookie is only valid for the time span of that the setting that you define in the portal and the gateway setting. And the other common option that they have also used is generating the cookie on portal and accepting it on the gateway. So in this case, what happens is that you are only generating the cookie on portal, so this cookie is still going to be valid for the time span, and it is going to be accepted on the gateway. You do not want the gateway to be generating the cookie in those use cases. And again, both these deployments that I just mentioned are basically done to avoid the double authentication when the gateway and portals are using the same authentication profile. So the use case number 2 is specifically for SAML deployments. So in regards to SAML deployments, what happens is that SAML requires the embedded web view or the system default browser. And in this case, starting 5.2, GlobalProtect supports SAML authentication using the default browser on the endpoint. The hardware security keys that are FIDO or U2F compliant are only supported on the system default browser. And in case of the system default, the browser tabs open up for SAML authentication, and this could be considered as slightly annoying for some of the end users. So the use of the authentication override cookies will reduce or could reduce the browser tabs, or get rid of the browser tabs for the entirety of the cookie lifespan, and it promotes a more seamless user experience. So just to sort of recap, the authentication override cookies can be used for username password-based authentication, and specifically for the LDAP, Radius, and RSA. We've got a number of customers that are able to generate the cookie on portal upon successful portal authentication, and then have it get accepted on the gateway. And this is basically done to avoid the double authentication. And in case of SAML deployments, this is also immensely helpful to promote a more seamless user experience. So with that, we want to take some questions, and Nihal and I and Sarvesh will be able to answer any questions that the folks on the webinar have.
So Kim, I think that there is a question that just came in. There's actually quite a few questions. It's been really busy and exciting here for this event today. Kim, do you see that there was one question for our experts that just popped in just now?
Yeah, that's from Remo. So what Global Protect configuration do you recommend for companies that use Windows Hello as Windows logging method to make the authentication as seamless as possible?
Yeah, this Sarvesh here. I'll take that question, and then others can answer as well to add some additional comments. So hello, Remo. So yeah, it's a great question. So today, Windows Hello can be deployed in 2 ways, as you're aware, right? One is for the desktop login itself, which is basically using any of those biometrics or Hello supported methods to just log into the Windows desktop. And so that is that can be supported today, wherein you actually connect GlobalProtect automatically using certificates or Kerberos, cookies, etc., or even any of those transparent authentication methods. So essentially, user will use Hello to log into the desktop, and GP will automatically start the connections using Kerberos, using certificates, using some other methods. You can even save username, password, credentials if you'd like. Not necessarily the most secure way. If you would recommend using Kerberos or using certificates. So that way we have customers who actually deployed Windows Hello, and it's a seamless sign-on process. The end-to-end, for example, if you are deploying Windows Hello for Business in the back end, today GP does not support carrying biometric keys from the desktop all the way to the endpoint. That's something we will consider for future.
Great. Was there any other questions that came in that we didn't address during the actual presentation, Kim?
Well, there were a couple other questions regarding the authentication override cookie. Where is it stored on the endpoint?
Yeah, okay, that's a great question. So the Global Protect cookie is stored in the Global Protect space, in the application space. We do want to call out a few things. One is the cookie is encrypted. So essentially, nobody, even if you take the cookie file, it's not readable. There is no certificate on the endpoint to decrypt it. The certificate used to encrypt the cookies are only maintained on the Prisma Access side or on the NGFW side. So the cookie is just an encrypted file. That's number one. Number two, that cookie is unique to that endpoint. So you cannot just copy that cookie to some other machine and try to connect with it. The cookie is actually bound to the endpoint. The third thing is you can also say that this cookie can be used only from that endpoint from one particular location. So as Varun was saying, you can say this cookie was issued to the user when he is working from home, and the cookie can be used only when he's connecting from home. If the user goes to a coffee shop, that same cookie will not be, even though the user is a genuine user, corporate issued laptop, you can configure it so that that cookie will only work from his home. If he goes to an untrusted network, he goes to a coffee shop, the cookie will not work and he will have to prove his credentials. So there are multiple layers to make sure that the cookie is secure. So I just wanted to add more information as I was trying to understand the thought process behind your question.
All right, thank you for that information. Also, when can I not use the authentication override cookie? That was another question that came in.
The purpose of authentication override cookie is to make the authentication seamless. It is not the only way. For example, if you're using certificates, your authentication will be seamless. You don't need authentication override cookie. So that's definitely one scenario I can think of right now. Also, if you're using single sign-on, wherein anytime the user logs into the desktop, automatically GlobalProtect is taking those credentials and using it for establishing the GlobalProtect connection, you probably may or may not require the cookie. So those are some scenarios where you may not need the cookie.
There was another question that came in from Remo in the Q&A chat. Is it possible to have the GlobalProtect connection information also on the login screen when Windows Hello is used? I don't know if that was already answered, but maybe that was an add-on.
I'm trying to understand the full context of the question. So when you say connection information, probably you're referring to the connection status. Right. So there is a feature that allows us to display the connection status. We will check on this one with respect to, because the Windows Hello uses a different credential provider than the previous the native credential provider. So we'll check on this and we'll come back to you, Remo.
So there were a few other questions that came in, but I think they were pretty much answered during the video. So how do we find out the host ID for each endpoint? But I think you pretty much showed it in the presentation, right?
So I can add a little more information to that question, Kim. So host ID is basically a unique identifier for endpoint, right? And so for the different endpoint and different OS, the host ID is defined differently now. So to give you an example, on the Windows, the host ID is defined as a machine GUID from the registry, right? Similarly, on the Mac OS, it is the MAC address of the first built-in physical network adapter. So similar way for the other endpoint OS, Linux, Android, iOS, Chrome, and Windows endpoint, the host ID is also defined differently, And we have documented this in our documents as well, externally under the feature guide. So that will be something good to refer there as well. Okay. I'll add that slide here.
Yeah, just one other point to what Nehal mentioned. Basically, if you know any information about that device, or if you know about the user, just go to the Global Protect log and search by the user, and you will see all the connection activity. You will see the host name from which he's connecting, and you will see the host ID. Or if you know the machine name, you can easily look up the host ID. So it is there in the log. So using any of the information you know about the user, his username or host name, you should be able to easily look up the host ID.
All right,
Great.
thank you very much.
Anything else, Kim, that came in that we didn't address from our experts today?
No, I think we pretty much covered everything.
Excellent. Excellent. Well,
Awesome.
with that,
we got some great questions, Cheryl. Just wanted to thank all the interactive questions. This is what made us feel excited about this session. So we have done our best to answer quickly in the Q&A. But if you feel you have more follow-up questions, please reach out to your account team, and we'll be able to engage and share more information.
That's perfect. Great. So this event has been recorded, and so we'll be able to post it on the Live Community dedicated YouTube channel, where you can see here on the screen the YouTube channel URL there. You can also visit the event page on Live Community for the direct link to the recording, and then also view all the questions and answers. We'll be able to have a recap, and it'll be captured there. And I wanted to say a big thank you to our experts, Nehal, Varun, and Suresh. You've been working really hard at answering those questions live today. And we really appreciate your time and energy and great information. So with that, we'll go ahead and conclude, and we'll see you all next time. Thank you.